Okay, so this is going to be a Kirchoff rule tutorial, how to use Kirchoff's rule. And we're going to solve 3 questions from Cutnell-Johnson. We have question number 1 over here, question number 2, and question number 3. So question number 3, as you can see, is pretty hard, but we're going to solve all of them. And okay, let's start with question number 1. So the first thing we're going to want to do is we're going to just label some lines. And the way I'm going to do it is every single line that connects to the junctions, so as you can see these junctions, I'm going to give it a label. So this label is going to be, this line is going to be I, or actually I'm going to label this A. This line is going to be B. This line is going to be C. So let's start. I can start off by drawing current flow arrows, and the way I'm going to do it is going to be based on this junction, and I'm going to draw like this. They're random, but all you have to do is not have them all flow into the same junction. So this flows through and this flows out, and so I can draw this line anywhere I want, but I'm going to draw it this way. Why not? And so we can start writing down some equations already. So the very first equation is going to be based on the junction rule, and it's going to be all the lines going in are equal to the output. All the current going in is equal to the output, so it's going to be B plus C is equal to A. Using the current diagrams, using current flow we have already, we can draw plus or minus signals on the resistors. And the way it's going to be is a plus will be the voltage behind the resistor is higher than the voltage after the resistor. That's how voltage works for resistors. So let's start. Here, current flows this way. The current before the voltage before the resistor is higher, or the energy before, not the voltage. The energy before, the potential energy before a resistor is higher than the potential energy after a resistor. And so this is going to be a plus. We know this side is going to be a plus because current is flowing through it this way. As you can see, follow the arrow and it goes this way. It's going to be a minus. You continue following the current. However, this line says the current flew this way through it. Plus, minus. And we already labeled our resistors, all our resistors. We can now use loop rule. And we're going to analyze loop 1, which is this box, this way, and loop 2, which is this box, that way. So both of these are counterclockwise. And let's see. So loop rule says that all the voltage drops should be equal to the voltage rises. So if we analyze it this way, we can see that the current going through this multiplied by the resistance, which is voltage, is going to be a decrease. So let's write it. B 2B plus, this is going to be a decrease as well. 8A, this is going to be a decrease as well. So plus 4 is equal to 0 because we don't have any rise, therefore the entire drop will be 0. We can do the same thing for this. So here we have a drop of 12 volts is equal to, and here we have a rise of 2 multiplied by the current, so 2B. We can solve this using a system of equations. It's pretty simple actually, because we already have a value for B from this equation. We can plug that in, solve for A, plug that in, solve for C. But we're going to use a matrix. The way you use a matrix is this. We have a TI-83. And you just draw a matrix using the equations. So here we're going to go to edit, and then we're going to go to our matrix. We have 3 equations. And so this is, we have 3 variables that we're, 3 equations. So that's going to be 3 by, and then we have 4 numbers. We have constants as well, including the variables, so that would be 4 So we have a 3 by 4 matrix. And actually what I'm going to do right now is I'm going to turn these equations into equalities for 0. So for the first one, it's going to be negative a plus b plus c is equal to 0. This one is already equal to, this one is going to be, or not equalities to 0, equalities to the constant. So 8a plus 2b is equal to negative 4. And 2b is equal to 12. So let's start filling them out. We're just going to grab the coefficients for every one, and this column is going to be a, this column is going to be b, this column is going to be c, and the column off the screen is going to be the constants. So negative 1 for the constant of this, 1, 1, and that's equal to 0. So enter. Here we have 8, 2, 0, and negative 4. Enter. There we have 0, 2, 0. It's equal to 12. Enter. So we have our matrix. And we're going to do some analysis on this matrix. So we're going to go to math. And actually, no, we're not going to go to math. We're going to go to matrix. We're going to go to math and matrix. And then we're going to scroll down to ref. Or instead of scrolling down, you can just press alpha B ref. And then we're going to put in our matrix. And that's this one. That's the one we just used. You can tell it's the one we just used because I had the 3 times 4. So it knows the matrix size. And we're just going to press enter. And analyze the matrix. And these are the values for the current for each. So that's the current for A, that's the current for B, and that's the current for C. The negative signals means you have negative currents. Obviously, there is nothing called negative currents, but the values are the same. The magnitudes are the same. So you can just treat it as a positive. So I actually went 1 for 3 in terms of current flow, not the best. But here we have our values for A, so for current. So E equals negative 2. E equals 6 amps. C is equal to 8. Okay, so we solved the first question. Now you can do whatever you want, whatever the question is asking you using current. If you want to know the voltage across the resistor, for example, for B, I know that the current multiplied by the resistance is equal to voltage, so we have B is equal to 6, so I can get the voltage drop across this resistor is 12 volts. I can do other stuff as well. But yeah, basically we have the currents for everything. We know almost everything about the circuit. So let's move to the next one. And it's this one. Nope, that one's way too hard. But this one. So this circuit is a bit simpler than the last one, but we're gonna still use the same rules. So we delete this. Actually, I'm not gonna clear the calculator yet because I can just go scroll up, press the enter. But yeah. So if you go here, we do the exact same thing. So this time I'm gonna analyze this junction. You can analyze the bottom junction as well, but what's happening? Okay, I was editing the wrong layer, but here we go. So we're analyzing this junction. I'm gonna do the same thing. I'm gonna label A, B, and C. I'm gonna draw current flow. I like doing this current flow every time. Obviously the lines are a bit rushed, but that doesn't matter. And let's put plus or minus on these. So current flows this way, plus, yeah, that's way too big, plus, minus, current flows this way, plus, minus, current flows this way, plus, minus, and let's do some analysis. I always like doing counterclockwise. I don't know why, but it doesn't seem to work too well for the terms for the negative signs. But it's always, I don't know. But yeah, plus minus, plus minus, plus minus. We just drew our resistances, and we can set some equations already. We have C and B flowing in, A going out. So B plus C is equal to A. B C is equal to A. We do some analysis. We have this going down, voltage going down across this, and this is the C current, 10C. This is also going down, plus 5A is equal to, and this is always also going down, so it's equal to 10, and plus 10 is equal to 0, same as last time. Here we have this going up, this going down. We're going to start with the down, 10B. We're going to have the down on the left side. So 10B, this is going up, this is going down, plus 2. So this 2 is this battery, which is this cell. So the 2-volt cell. So this one is going up, so that's C again. C, 10C. And we have the 15-volt battery, plus 15. So we have our equations. We just restructure them again, leaving the constant on the right side. Negative A plus B plus C is equal to 0. 5A plus 10C is equal to negative 10. And we have 10B minus 10C is equal to 13. So we have our equations. We go back to the calculator and turn it on. And we go back to the matrix. We're going to just edit the matrix. I'm going to use the same matrix because I already have the equation written down for it. Negative 1, 1. So let's just double check all of that. Negative 1, that's correct. 1, 1, 0. And so, get this equation correct. Let's go back here. This one is equal to 0. Wait. I don't know what happened there. Second matrix. I see. This one is equal to 5, 0, 10, negative 10, 0, 10, negative 10, 13, second, quit. You can't scroll up using this calculator. Okay. Gonna press alpha B. Second matrix. 1. And we have our current values. Again, 143. I think this is a new record, but we have our values. A is equal to negative 0.35, or not negative 0.35. B is equal to 0.475. C is equal to 0.825. Okay, so this one was actually exactly the same as the last one, but the next one is not going to be as easy. Let's delete this layer. Turn this one on. Okay. What am I editing on? Okay, here we go. Okay, so this question is really hard, or not really hard, but it's a lot. Okay. So yeah, this question is a lot more work. Let's start. So this time we have a lot more seconds. However, we can just keep on working with it. So I'm just gonna start off by observing how many lines connect to the junctions. We have this line connecting to the two junctions here. This line connecting to the two junctions here. This line connecting here. This line connecting here. This line connecting here. This line connecting here. So we're gonna have 1, 2, 3, 4, 5, 6. 6 variables. So that's a lot. And we're gonna analyze more than one function junction, but let me draw out some lines for the variables. Let's go to here. This one is gonna be A. We're not even gonna look at the variables they give for the junctions. We don't care about those. This is gonna be A. This one I'm gonna give B, C, D, E, and F. And then we're just gonna draw some current flow of this flowing like this flowing like this. And you want current flow for almost every junction that matters, right? Like for example, in this junction, right? If we have current flow going this way, current flow going this way, like indicated by this junction. But yeah, so you're just gonna need to have some current flow, just understand how the current's gonna flow. Here I can draw it going this way and that way. So there, here, there, and here I can only go one way, so like this. Here we go, we finished the current flow. We have current flow going this way, this way, this way, this way, this way. So we have our current flow. Let's draw signs. Plus, minus, we know this drops, plus, minus. I'm doing this a lot faster because by now it should be obvious after doing like 2 questions. But yeah, it should be obvious how I label the signs. Plus, minus. Draw some loop analysis. And I'm not going to actually care right now. I'm just going to write down the equation. I'm not going to draw the circles for the loops, but I'm just going to write down the equations first. So at this junction, right? Junction, what they labeled C, I can draw, this is going in. So A is going in, C and B are coming out. So A is equal to B plus C. Here at junction B, B is going in, E and B and D are going in, E is coming out. B plus D is equal to E. Here we have C and D, C going in, D and F are going out. So C is equal to D plus F. And the last one we have E and F going in and A coming out. E plus F is equal to A. You're always going to end up with a lot of junctions that are really obvious. You can just calculate them using this. That's always really nice. Actually, no, we're going to remove one of the equations because as you can see here, if we do it like this, none of the equations are going to involve the 20-volt battery because we can only analyze 2 loops. So I'm going to delete this one, but we're going to need to have an equation analyzing every battery or resistor on every line, at least using the loop rule. Because as you can see here, this loop, if I draw one here, one here, one here, there is no way to analyze all the resistors and volts using only 2 loops. At least no simple way I can think of. Actually, yeah, I'm not gonna complicate this too much. I'm just gonna write the stuff down, and later on I'm gonna analyze some, and I'm gonna try to simplify the loops. So we have our first loop. I'm gonna make it this loop, this loop, this loop. I'm analyzing them all counterclockwise. I'm trying to stay consistent a bit, but here we go. Let's do some analysis. We have this going in. So I wanna, this is a plus, this is a minus, so 20 is decrease. Plus minus, plus minus. So these are all increases, so that's plus 50C plus 20F is equal to 0. Decrease, increase, increase. So 70B is equal to 50C plus 60D. We're almost done. We're going to need 6 systems of equations because we have 6 variables. Plus, plus, minus, plus. So we have, this one is a decrease, 60D plus 40E is equal to, this one is an increase, so that's 20F. And as always, reform everything so it makes sense. Minus B minus C is equal to 0. D plus D minus E is equal to 0. C minus D plus F is equal to 0. We have, gonna put this on the side, 50C plus 20F is equal to negative 20, 70B minus 50C minus 60D is equal to 0. Finally, 60D plus 40E minus 20F is equal to 0. So as is equal to 0. Okay, we have our system of equations. This is a lot of system of equations, but that's okay. It should work out. Turn the calculator on. I'm going to use a different matrix this time because I benefit nothing from using the previous matrix. And 6 times 7, 6 equations, 7 values, including constants. So we have, this is going to take a while, but we have 1, negative 1, negative 1, 0, 0, 0, 0. We have 1, 1. Oh wait a second, I answered this wrong. Yeah, that's BD. Okay. 1, 0, 1, DE, negative 1, 0, 0, and then we have 0, 0, 1, minus 1, 0, 1, 0. Okay, we have those. We have all the ones using the junction rule. 0, 0, 50, 0, 0, 20, negative 20. Okay. Yeah. Don't think I wrote the negative there. Negative 20. And this one is 20. don't know what happened there. Okay, 20, negative 20. We have here we have 0, 70, negative 50, negative 60. Those are all zeros. I'm not gonna bother putting 0 every one of them. Just gonna skip. 60, negative 40. Actually, not negative 40. 40, 20, or negative 20. And 0. Second quit. We're gonna do again the reference. And we're gonna go again. Then we're gonna put 2. And we have our values. Scroll out a bit. Yep. Yeah, they have a lot of significant digits. However, I think this answer is correct here. I don't remember the answers if they're correct. They might be wrong. I might have messed up, but I think they're correct. Because yeah, I think they're correct. 1.26. B is equal to 0.32. What? 3, 2, 6. C is equal to 0.930.